And
right.
it says
Now
we're
the
live.
question is, did it work? Are we live? Are we simulations?
I'm a figment of
A pigment.
figment of pigment.
And that board in the top left is definitely a figment of my imagination. It's just a fever dream gone wrong.
It is. Hey, welcome to the show, Jonathan. Good to see you, Bill.
Yeah, welcome.
Hello,
Good to see
everyone.
both of you.
Great to be back.
It's nice to have a decent quorum of people jumping on right away. And this is a very cool project. I've been very excited to see this. And I want to say it couldn't have arrived at a better time. The board and the components that I had to solder on, the box you sent me as part of the beta team for this project, arrived literally last Thursday. So 8 days ago. That was the day before my birthday. I'm like, this is the coolest birthday present. As far as electronics, you know. So people, what we're looking at here is the Neotron. We've talked about this once before on the show. That was probably 6 months ago or so.
Yep, I think you were looking at Rev 0.5. This is Rev 1.1. So hopefully almost all of the bugs have gone. Hardware-wise,
so
anyway.
It's and back then we were just going through it in the KiCad or KiCad. I'm never going to say it right because it's not my tool. But it's nice that you've the whole project is open source thoroughly, from the library of parts in CAD all the way up to the software stack. But tell us why you designed this, Jonathan. This is very cool.
Yeah, so why does this exist? Because as with many middle-aged people, I'm a child of the 80s. We grew up on computers like the one ones Bill put together. And it seemed to me there's a gap, right? You can get open source hardware, but it's generally either an Arduino, and so it's a microcontroller and it's an embedded system.
Keyboard controller, yeah.
Yeah, and so by that I mean it's a computer where if I walk up to it, I cannot command it to do something else because it requires plugging into a larger system. And then you get computers like the Raspberry Pi, which are great fun. They are general purpose computers, but I can't understand a Raspberry Pi from top to bottom because there's a giant Broadcom system on chip that has a 5,000 page data sheet that I'm not even allowed to look at.
Yeah.
So
it's not really open source. They used open source for marketing, but what they really meant was we're using an open source operating system and an open source Python. Python.
Yeah, and I get why if you're making a commercial product, there are issues around just giving everybody the ability to cheaply clone your product. So it seemed like there's a gap, right? There's microcontrollers and there's big systems. Oh, and I should mention there's a bunch of sort of retro vintage inspired tech up on the shelf behind me, just out of shot. There is an RC 2014. It's a fantastic Z80 based machine.
Those are marvelous.
Yeah, it's a great kit computer, but it uses chips from the 70s. And when I program it, I have to go back to the 70s. I've got to write Z80 assembler. So I thought, okay, what I want is something made out of brand new chips that I can actually buy, that I can assemble myself like an RC 2014, but that I can compile and run sort of more modern software. But I don't want Linux. I don't want something complicated. I want like MS-DOS on an ARM microcontroller. So that board is basically tailor-made to run my homage to MS-DOS on an ARM microcontroller. So it's trying to hit a sweet spot in the middle that nobody else seemed to be hitting. Everything seems to be Z80 or 6502, or it's a more complicated thing and it runs Linux.
Well, I think this is an awesome machine. I was truly inspired when you first started sharing it on our Discord. So, by the way, if you're new here or if you're seeing this for the first time, there's a lot of detail, a great thriving community, mostly into retro, but a lot of just engineers and electronics hobbyists and makers even are on our Discord. So definitely head to coriolis-effect.com and join the Discord. You'll see there's a lot of birds of a feather to flock together with up there. I'm just going to put that on the ticker so you'll see. So if you go to that site, Bill, thank you for setting up that site. At the very top, there's a link that says Discord. That's how you join our Discord. That's an open invitation link. There are some rules. We want to be polite, and this community is open to anyone of any age or background. So, yeah. And Jonathan, we first saw this and invited you to join the show a while ago because you posted about your first rev of this. You posted some pictures and explained what you were doing, and I got really excited. I'm like, that is a seriously cool project, because I thought, I've been messing around with Raspberry Pi Picos, which is the RP2040 chip. So most people by now realize that's a dual core ARM Cortex M0 Plus. The plus means it has single cycle multiply, right? Probably means some other things too, which are really cool.
Yeah, I don't think hardly anyone does an M0. I think most of the M0s kicking around are the plus
these days, right?
Yeah.
And within what that means is, like, to someone like me, I'm into audio signal processing, and I'm always dreaming about guitar pedals and things like that. And I'm like, I could seriously put this $1 microcontroller, if I buy that part, even in single unit quantities, as a standalone QFN chip, it's $1. Or if I buy 1,000 or 500, it's 80 cents. And this thing is a dual RISC microcontroller with, what is it, 256K of RAM?
256K of, I think, single cycle internal SRAM,
so
which
really
is actually
fast.
Split into 6 banks, and the banks are all interleaved. So it's like RAID 0 SRAM. So you should be able to have like both cores running and a PIO engine running and a DMA, and they all have like a bank each to work out of.
And however much program memory I want to attach to it with a quad SPI, so that's really fast. I mean, it's a serious device for such a cheap part. It's like it's pretty hard to go past it, and I like, there's so much you can do with it. And I saw this platform, and we got talking about Rust, and it's almost like you've built the ideal embedded Rust development environment as well for people here.
Yeah, and that was one of the goals. I'm a big fan of embedded Rust, and there are a few boards kicking around for doing Rust development on, but they tend to be microcontroller based. So they are embedded systems. You need big computer to plug in to program small computer.
Yeah.
Whereas I wanted a computer that is standard. Now, to be clear, that computer is never going to run the Rust compiler. The Rust compiler needs like 2 gig of RAM, and I've got 256K. But it's a nice combination of, I can write, if I want to write a programming language, I need a parser. Well, I can do that in Rust. It's a fantastic language for writing text parsers in. There's great libraries for it. So I could do all that, and I can write my own version of BASIC, but I don't have to do it in ARM assembly like you would have had to do on the, like on the old BBC Micro. The BBC BASIC is written in 6502 assembler. I can't. I'm not that kind of software programmer.
Yeah, I don't think many people have time for that kind of endeavor, but given the thriving open source community around ARM now as well, there's got to be things out there that could easily be ported to this. This seriously could be a standalone desktop platform that's more performant by a long shot than what I had in 1992.
Yeah. So if I move out the way in the background, selection of various machines. There's a Commodore 128D down there behind my name tag. The ARM machine there, that is an ARM RISC PC. I saw that last time I was on the channel. That is an ARM 610. So it's a V3 of the ARM architecture. I think came with like 2 meg of RAM as standard. That's clocked at 30 megahertz. So this Pico, the chip is clocked 4 times faster, and 133 is the conservative number. That's what they'll do over all temperature ranges. Like even if you're at the edge,
put a little heatsink on it, you could push it a bit harder.
Oh, people will have no problem running that at 250, and I've seen them run at 400.
What?
Wow.
That's mind blowing.
Yeah, no,
How do
there's,
you-
there's
but,
headroom. And
that would require putting a different crystal oscillator on the board.
No, it's all driven for the PLL. So there's just like a 16 megahertz input.
So
And
they
all
let
PLL
you
inside.
do that from software.
Yeah.
I like it. I'm definitely
Yeah,
going to
just-
be trying that.
Just clock it to whatever you want. So
That's
the
brilliant.
reason 252 is good is because that lets you push DVI video basically bit bashed, because you need 25.2 megahertz and there's 10 bits per pixel. So at 252 megahertz, you can then push out VGA video over DVI, just doing the TDMS link basically in software.
That
Wow.
is serious. That
Yeah.
is serious. So there were some really cool questions in the comments here. Like Bill, you brought this one up from Neuromod. Besides being ARM and having PIO. So for those who don't know as well, PIO is actually a significant advantage of the Raspberry Pi 2040 chip. Many chips, I was talking to a friend on the phone, Eli, who's also been on the show before and a member of our community, last night on the phone, and he was telling me there are other parts coming out on the market that have similar capabilities, but the PIO is a very special thing, and I'm still learning about it. But it's almost like there's another third processor, or some kind of programmable state machine that'll essentially means you can make your own customized IO interface that runs at full speed or whatever. So
it's like a processor with about 6 instructions. I'm holding up 5 fingers, 6 instructions. And they're basically you can jump, you can increment a register, you get an X and a Y register, and the most important ones are you can shift in from FIFO and shift out. So that will grab a set of GPIO pins. They have to be consecutive, but you can pick any consecutive run of pins on the chip. Say, I want to grab those 8 pins, shift them into the FIFO. So if you can describe your protocol in terms of wait for this bit to be set, then shift in some bits, then set an output, then wait for a bit, the processor will do some work, then shift some bits out onto the bus. If you can describe your protocol in those terms, the PIO state machine will do it for you with clock cycle perfect accuracy. Even if you get an interrupt, and even if your processor wanders off or gets a stall because the flash isn't cached, the PIO will just do its business.
That's pretty powerful.
VGA video, we've seen people do DVI video, so that's basically HDMI, I2S audio. If you want an extra SPI bus, that's trivial to do. That's like 6 lines of PIO code, but you've got an extra SPI peripheral, extra UARTs. If you want the infrared UART with an extra clock line, that's trivial to implement. And you get 8 state machines, 4 PIO blocks, 8 state machines included.
That's great. So we're using one for bit banged VGA output.
2, because the other one does the horizontal and vertical sync.
Got you. Perfect. So then we have another for I2S, which I love because I'm gonna definitely get
got
audio
16 bit stereo audio.
Brilliant. And then another one for SPI for all the other peripherals on the board.
It has a hardware SPI block, so actually I only need the two PIOs.
That's cool. That's very cool.
It's got hardware SPI already.
Okay. So and I'm one of these days I'm gonna have to get a lesson in how to pronounce Kersar's name, but I'm probably way off, so I apologize. But a regular viewer, so thanks for joining us again. So what does Rust closely resemble? Does it resemble?
So it's kind of, it belongs to the sort of the C family of languages in that it uses curly brackets, as opposed to the Python family of languages, which use colons and then very important white space.
I
hate that. That's my one gripe about Python is you can have something that works perfectly and you can copy it and paste it and it won't run because the indentation got messed up. And it's like, what?
Terry Ryan, who wrote BASIC for the 128, sent me an email yesterday, and the punchline was bad indentation on Python.
Yeah.
Being the culprit. Yeah.
So it's not like that. It's a curly bracket language.
It's a curly bracket.
So there's this subclass of languages we call systems programming languages, and they are the languages you could use to write the first thing that runs on your computer. So JavaScript, not a systems programming language, because someone needs to write the JavaScript interpreter. That has to boot first, and then you run the JavaScript on top of it. Basic, can't do systems programming basic. You need a basic interpreter, a basic runtime. C#, you need .NET. You need this sort of garbage collected system running under the hood to manage your memory for you. Can't write a bootloader in C#. C, there's nothing underneath you. You're generating pure machine code. You can flash that into a ROM chip and boot your computer with it. C++ is the same, and that's where Rust fits in. So it is a systems programming language. It produces raw machine code we can boot the computer with. But
I like that.
It takes lessons from the last 20, 30 years of academic research into programming and gives you a language where it's basically impossible to do a buffer overflow, because it's either checked at runtime or the compiler proves that everything is fine statically at compile time, and then it can delete the checks. Wow. So you get a memory safe language where it's much harder to produce buffer overflow bugs.
No uninitialized memory pointers. Then
it is impossible to use uninitialized memory in Rust unless you
do something
deactivate
wrong.
The safety catch. There is a safety catch, because if I want to write to a UART, what does my UART look like to my program? It looks like 3 addresses in memory, and the compiler's like, you've literally just conjured these pointers out. That was a number a minute ago, and you've turned it into a pointer. And I have no way of knowing that this points to valid
stupid von
memory.
Neumann architecture.
You didn't allocate this. What's going on?
So I would say that even lends itself to an inherently more secure language.
Yeah, no, absolutely. And people say, Rust, it's never going to catch on. They say there's a great quote from Mara on Mastodon, and I'm going to mangle the quote, but it's basically like keyboard warriors going, Rust is never going to catch on. They said sending an email in Thunderbird, which has portions written in Rust, to a mailing list that's hosted by Fastly, who use Rust, which is backed by Cloudflare, who use Rust, and they store the mailing list on AWS, who use Rust, and then they go to a Facebook group to complain about it, and they use Rust, and Netflix use Rust, and Microsoft use Rust. I mean, maybe all of these people are wrong. Maybe all of these $100 billion companies have got it wrong. But I mean, they're all calling me up and asking for training because they need to get more engineers trained. And They all seem to be writing blog posts and saying, this works. We cut the number of servers we need because we were running Python and JavaScript, and now we write Rust and it goes faster. Or, we were writing C and now we have fewer bugs. So it's as fast as it was before, but there's less bugs in it.
So I think training is going to be the thing, right? I mean, it was easy to hire new web developers or service developers or backend developers because Python made software development very accessible to hundreds of millions of people in the last 10 years. But Rust is a more serious, like, computer scientist.
It requires a
language. So the next step is, it's gonna be more investment for the individual to learn up front, but it's gonna pay off on the back end.
Yes, so, I would say that I sell the training, but that is genuinely my view, that it's worth the upfront investment, because you'll just have a better time. You'll write software faster, and your software will work better and have fewer issues.
Yeah. So that was our last episode with you, Jonathan. So I should have looked for it ahead of time so I could refer back to it and provide a link. That stream was recorded on Bill's channel about 6 months ago. So if anyone wants to learn more specific about Rust, we really honed in and focused in on Rust on that particular episode, particularly around embedded systems. I wanted to quickly, we were talking about the hardware and the reasons behind why Neotron exists. But well, first of all, let's bring up the board view more.
So I'm really keen to hear your feedback on this, Ben, because I'm a software engineer and I've used other people's schematics, and I've watched excellent channels like Phil's Lab where he talks about things you shouldn't do in a schematic. So I think I've tried to do them, but you know, you look at schematics all day, every day, like I look at code. So I look at code and I can immediately go, that smells funny. So I'm hoping you can look at schematics and go, yeah, that seems weird, man. So I want to hear your feedback on, on how it feels and how it smells.
I will. First of all, I do really like it. But the general feedback is this is very nicely done, and I'm impressed with the quality. So what we're looking at here, you'll see there's some expansion slots. So it really is following the model of a typical desktop PC, and you've used what is like this similar kind of card slot that ATX used back in the day.
Yeah,
only
it's
a much
same
shorter
pitch as an ISA. Yeah.
Right, ISA bus, yeah. But instead, we're using, because we have very limited I/O on the master device. So it appears that we're using SPI and a bunch of chip selects and addressing to give us some different options. So we're sharing an SPI bus. The question is, what's the planned speed of operation? Because that's going to be a bit of a bottleneck to some applications. I think technically or theoretically, we can push SPI up to 25 megahertz pretty easily. The board is a 4-layer board, so you've got reference planes inside. We'll look at that in a moment. So my opinion is, speed-wise, the physics of the board should cope with it, no problem. What could be some of the things that might be an issue with that?
Sorry, how do you mean?
Getting enough speed to add multiple different cards. And
yeah, so I remember Bill talking about designing the C128 and trying not to have a tree, right? So the bus should be like a sort of a linear bus with not too many stubs coming off it, but
yeah,
it's card slots, and then who knows what's actually going to plug into the slots.
Yeah.
So I guess these signals, you know, when you got a card like that plugged in, you got signals flapping everywhere. So there is some attempt at slew rate control. So if you look just above every slot, if you just tip the board, there is a pad for a capacitor and a 0 ohm resistor, and that's on the output of every slot. So
okay.
if you do need to limit the slew rate, then you have some options there.
Okay, I like how you've labeled everything so clearly, because slot 1, it's like at one of these, it's all the same, except it's taken up by the onboard SD card.
Yeah.
So just so everyone knows, so this board was shipped to me, the battery holder, all the headers, the push switches, any of the through hole components here, the Raspberry Pi, all of the I/O headers and power connector, and these card edge connectors, none of that stuff was affixed. The through hole capacitors and that inductor and this switching regulator module, I had to solder all of those onto the board, but it seriously took me about an hour to get everything done. It was very easy. So what we have AC97 audio jacks, and there's a standard pinout AC97 header there. So you can mount, this board is actually a mini-ATX form factor and could go in an actual ATX computer case. And well, we don't have a back plate to match this, but perhaps from the 3D model, I could actually design one that could be laser cut or something. But we have the VGA port comes direct from the Raspberry Pi. That makes sense because we're going to need some more I/O speed for that one. And that's a pretty decent color range you've got there. A lot of resistors making an R2R DAC. So we're doing
4 bits per channel.
Yeah, so it's going to be a decent color range.
Same as the Amiga, 4096.
Yeah. The Raspberry Pi, I did solder an additional header on top of that for the Raspberry Pi's own debug connection. this is PS2 keyboard and mouse connector. I'll see if I can get that to work.
Yeah, PS2 keyboards, they're getting hard to find, aren't they?
The only other comment I have here is these caps that shipped with it are not the same as what the footprint was. They're a different lead.
Yeah.
So
I'd already bought a bag of 200 caps at that point, and I'm like, stuff it. You're getting them anyway. You just have to have a bit of a wobbly leg on them.
It's okay when you're hand assembling something. It's totally fine.
Yeah, I imagine a through-hole like pick and place machine is going to have a bad time with that because they will not go all the way through to the board.
We have a real-time clock now. I'm not sure how that connects into the whole thing. The audio codec has its own dedicated I2S interface, and you've actually labeled on the silk screen all of the actual connections on the other side of the Raspberry Pi 20 Pico module. There's silk screen labels about what everything is. This has got me curious. This slot 0 is actually a board management controller, which is another Cortex M0 micro.
Yep, and weirdly costs more than an RP2040.
That's not surprising. ST microchips have totally inflated in price the last couple of years.
Just to go back to the real-time clock, I can quiz you here. There's clearly 2 wires going between the audio codec and the real-time clock. What bus interface would both an audio codec and a real-time clock have?
Oh, I2S. I2C.
I2C. Yes, because the audio codec has volume control. So you need I2C to configure the clock rates and the volume. So the bus routes its way round, and it visits the RTC first, and then 2 wires go up for I2C on the codec.
Makes perfect sense. And I2C, I thought I saw somewhere that's exposed on a header as well. So you can
it comes out on all the expansion ports as well.
And so you're saying it goes to all of these as well. So that makes perfect sense as well, because a lot of peripherals you might want for a platform like this, they're not necessarily going to be high speed. They just need to be convenient.
Plus, it allows you plug and play. So the address pins are for like a 1 kilobit I2C EEPROM. So these EEPROMs normally have 3 pins on the package, which you can pull high or low. And basically the binary number you put on the address pins gets added to the built-in I2C address. So you can have 8 EEPROMs on the same bus, provided you configure their address pins separately. So every expansion slot on this board has a unique combination on its address pins. So that means if you drop an I2C EEPROM onto your expansion card, on startup, the main processor can cycle through
and see which card is in which slot.
And it can read the EEPROM, and the EEPROM can tell you who made the card and what drivers you need for it to work.
Yeah. I like that. That's very cool. And all of these also, all the slots, quote unquote slots, because they're not all slots, but each one can generate its own interrupt requests. And these all feed back to different interrupt lines. So I believe that's what I'm seeing here is chip selects and interrupt requests. So tell me about this. This part, the microchip 22S17.
Yep, the 23S17. So the only DIP chip on the board, which might tell you something about the availability problems I've had with it. So we ran out of IOs on the RP2040. I think there's 26 or 28 on the Pico PCB package. And I'm using the Pico as like a giant DIP package, because if you squint, it's basically just a DIP chip, right?
Yeah.
Right. And I'm using 14 of them for the video, and I need another 6 for the audio. So I'm really running out of pins. So this is an SPI IO expander. You send it little messages over SPI, and it has 16 pins that can be inputs or outputs. So you get 5 LEDs. You get 3 are decoded into 8 chip selects to make sure you can't accidentally chip select 2 things
this
at the
is
same time.
138 decoder right here.
Yep. And then you get 8 interrupts. The interesting puzzle was, how do you, if the system is configured and a chip select is active and you're talking to that device on the bus, how do you use the same SPI bus to reconfigure the IO chip to deselect the chip select, because as soon as you send the message to the IO controller, it's going to go to the expansion slot because you've got the chip select active. So the trick, it turns out, is I managed to find one spare IO line, and you can disable the 138 decoder.
Oh, okay.
So you disable that, and then all the chip selects go high, and then you can talk to the SPI IO controller. And the reason it's DIP is because that chip is 99.9% pure unobtainium. It is just it seems to be in everything. Normally the QFN package version, like I imagine your washing machine has one in, because it's just a really useful kind of general purpose IO device. It costs about $1, and you just can't buy them. I just haven't been able to buy them for about a year.
So how do we get around this? If people want to build this board, how are they going to get a hold of that? Do you have any?
That chip is available as a QFN, an SSOP. So is that the super small outline package? It's available as an SO, so the small outline. That's kind of the chunky format, and it's available as a DIP. The DIP is not quite as bad as the others. Let's just call up Octopart. Other part sourcing companies are available, but I'm just going to call that up here and just see what I can see for the availability, because it's normally 0. So today, DigiKey have 149, and the microchipped factory outlet have 1,000 in stock.
Oh, so okay, that's not a problem for people like us who want to build a open source.
Because we're getting to the end of the great chip shortage, I think. So that part in the DIP form factor is available. I'll bet if I called up the SSOP or the QFN version, QFN, absolutely nothing available, because that's what a production company would use.
Just looking a bit more through this, let's look at the schematic. So it is a pretty elegant design you've got there. We just have the main Pico is on its own sheet here. That's pretty straightforward, easy. Looks like we're not trying to do anything complicated with power or ADC references or anything, but you've basically used every single available IO on this. It's taken up between VGA, like you said, that's using the whole first 14 IO. Then we've got I2C, then we've got SPI bus, interrupt, and I2S is taking a bit. And so it makes sense, right? So what's the shortcut? Alt backspace. I'm learning KiCad while I go. So the IO expander, that chip we were just talking about, is right in here. So I think the next thing might be design some little carrier boards that convert the smaller versions of this chip into a DIP, so someone could plug that in if they were able to get that one.
So I can tell you a funny story. There is an S18 that goes alongside the S17, which is open drain. Okay, that's fair enough. In some cases, you don't want to push-pull your outputs. You just want open drain outputs. So I bought a reel of 50. I don't know where I put them. A reel of a tube of 50, because they're DIP. They come as a tube.
But you've got pull-ups on everything anyway, so that's no problem.
Except
it'll slow these down, because if it's open drain, a 10K pull-up is pretty weak.
Yeah, there's a bigger problem. So I bought 50 of them for about $2 each, and I was using my last remaining 17s. And I went to build one with an S18 on it. Didn't work at all. Just no access to the bus. That's weird. Maybe I've blown the chip. I'll put another one in. Nope, nothing. Put a 17 in. Everything works fine. Well, this is weird. I mean, it's just an open drain version of the S17. Yeah, no. Microchip moved all of the pins around in the package because they deleted one of the address pins, and everything else shifted around on the package by 1. Power and ground aren't even in the same place.
That is utterly asinine. Why they would just
Yeah,
That's a real
rude words were
that's
uttered.
not a good decision.
It never occurred to me to look at both data sheets side by side. So earlier versions of this go, yeah, you could just plug in an S18. Readers, you cannot plug in an S18. That absolutely does not work. If anyone wants to buy some, I've got a tube of 50 that I can't do anything with.
Wow. Okay.
You have a nice clean layout style on your schematic, by the way.
The schematics
Thank
do
you.
look very nice. They're very legible. They make
Left
sense.
to right. Yeah.
I like the way you partition and label them. It's really nice. It's how I used to do reference design schematics in Altium back in the day. So I see we've got all the sheet IOs here. Right, these are the KiCad version of sheet ports, I guess, for hierarchy, and so
there's a question. Do you like to scatter your sort of your input output ports all over the page, or do you prefer to stack them up in a corner and convert them to local labels for the sheet?
This is not a best practice necessarily, but my personal preference is it depends on the type of design. In a digital design like this, it's pretty much all digital. I would do what you've done because it just keeps the schematic more readable. And people sometimes say, well, why do we even need schematics? A lot of people, especially software people, no offense, but who get into hardware are like, why do you even need schematics? You can describe the whole thing in a language. It's like, well, you might as well just go ahead and write a netlist then. You don't want to be writing netlists. Okay. Yeah. I actually knew an EE who, through whatever circumstances, went blind, but kept developing using VHDL. And because VHDL can be used as a netlist language as much as a description or behavioral language. And so that's astounding, and I was really impressed. That's fantastic that you can do that. Generally speaking, the schematic does convey additional meaning that you don't get just by, like, you could describe it in a language, but so my personal philosophy, and you don't want to get into a fight with me over this, is schematics will always be necessary. There are certain things that one day will optimize out of them. That might be things like decoupling caps, where you just have a massive bank of caps on one page, and you're
and drawing out something like this.
This is ridiculous. I should be able to just put a block that says we need this many caps of this value. That's the part number. Therefore, this chip, and it becomes like a cow and calf situation, right?
Especially in a tool like KiCad that doesn't have great multi-select. Like, I can't select all 10 0.1 mic caps I put on a sheet and then set the footprint for all of them. You kind of have to click on each one, and you just think, oh, this is, if I was writing this in like, this is 2 lines of Python, just 4 cap in all of my caps, I want to do that. So maybe they're going to add some scripting features to KiCad to help you out there. But yeah, there's definitely some occasions where I thought this just feels a bit like a manual task, and I should be able to automate it.
One thing I feel is missing, and maybe it's just a view or window I don't have open. Oh, that's it. I was looking for this. I didn't know they had.
I didn't know they had
the
that.
hierarchy manager. So there needs to be. How can I get this to dock? Can I make this dock somewhere, or is it always going to be floating?
But as you dragged it to the side of the screen, it seemed to change shape. Does that?
That's only because of the DPI settings from one monitor to the other. I do like this though. Oh, but why does it disappear? Come on, guys, get it together. We need a folder view like other hierarchical tools, professional hierarchical tools like Altium.
They'll have like a folder pane.
Or KiCad. It will be a docked panel that has a folder hierarchical folder view.
It's
and
Windows Explorer versus my computer. Like, the experts want Explorer because you need the tree view on the side.
This is better than nothing, but yeah, it should be dockable and it should stay open. I don't know how to do that in KiCad. Maybe there is a way and I'm just not good at it. Yeah, so tell us about the BMC. I wouldn't have thought you'd need a board management controller, but there must be some decent offloading you can do. Given that this is another full-on ARM processor, it's probably like a sledgehammer to crack a walnut in its roll. But
it is, but it's like a $1.20 sledgehammer. So I could have used a pick and I could have written it in PIC assembler, but that's not my idea of a party. So
right. It's not
I
a lot
just
of fun.
pay a few extra cents and put an ARM control. I mean, it's weird. It's the kind of the same sort of processor core as the main processor. But so what does it do? Well, if we go sort of round clockwise from the top on the right-hand side, power rail monitoring. So it's 2 ADCs to monitor the 5 volt and the 3.3 volt rails. Because I thought, hey, PCs have a BIOS page that show you your power supply voltages. So I want one of those. I only have two voltage rails, but it's kind of nice to know that the regulator is working. So we'll monitor those.
Well, that's good. There's a reason that is needed in a PC context, because you're adding in other peripherals, and the manufacturer of the motherboard can't tell if you're going to exceed the power capability of the main board to supply to those cards. So you want to make sure, right? If I go and add some kind of stepper motor driver cards in, I could be dragging that 5 volt supply down to its knees and wondering, oh, why is my software not working? Well, maybe it's because there is a legitimate need for this kind of thing, is all I'm saying.
Which is good, because I just come at it from the point of, wouldn't it be cool if it did what a PC did? So the next thing on there is controlling the case LEDs. At the bottom is a 8 ohm PC speaker. So
this one here.
Yeah.
That's
standard one of those. It's a little transistor driver.
Hey, I got a question. Why is there an HDD LED when there's no? Excuse me. Excuse me. When there's no actual hard disk drive, we have flash on board the RP2040 Pico module. What else would we be using the HDD LED for in a PC?
The SD card.
Hey?
The SD card.
SD card. Gotcha. Okay.
Yeah, it's removable mass storage, and it's fat. So if you eject it midway through a write, you trash the card. Because this is an 80s PC, and that's what happens.
Yeah, it is. Well, actually I didn't have flash until the late 90s.
Yeah, SD cards are weird, right? Because they just still emulate a 512 byte block ID hard disk that we've had since like 87, 88. I think MFM went away, but the hard drive LEDs for the SD card access. It also doesn't come from the BMC, because the BMC ran out of pins. So that comes from the chip select and interrupt controller. So I said there are 5 LEDs. There are 4 on the board, and then the 5th one is the hard drive LED. Got you. But isn't it annoying on a PC motherboard where they give you a pin header for the power LED and the hard drive LED? They don't put the LED on the board. So if you're running the board bare on the desk without the case, you can't see the lights. Yeah, that's irritating. I paid the extra 10 cents, and you've got LEDs on board. I like that. Thank you. And you've got 6mm push buttons for power and reset as well. Is there a cross probe tool or highlight tool in KiCad where I can click on a net and it highlights all the other places it goes? I should know this. Yes, probably. If you pull open that menu, I'm sure there is, but I can't remember what it is. I think it's on that menu somewhere. Change to hierarchical, global, blah, blah, blah. Select all, maybe? Zoom. No, that's literally a select all. I'm sure I've done it. I'm sure I've done it before, but maybe in the comments, someone who knows KiCad can say, "Hey, there's a shortcut key or a key modifier." So if we keep going around the board, the next thing on the sheet after the speaker, maybe I should have added a DC blocking cap, because I am a little bit worried the PWM output will get stuck high, which means the coil will end up possibly fully in. But those little PC speakers have high end.
Whoop, we lost Ben here.
I've lost Ben as well.
Hello?
Yeah, Hello? You're back.
You're back.
I was going to say that I think the DC resistance of some of those cheap PC case 8 ohm speakers is high enough. Right. It's probably not. I mean, you put a 33 in series, it'll probably be okay. But a lot of them are just a piezo element, and those are essentially a capacitor.
Right.
So you can get away with it with them, no problem. So and then obviously we've got keyboard and mouse. PS2 keyboard and mouse. 5 volt open collector. So weirdly,
the clock comes from the keyboard or the mouse. So the BMC has to watch the clock edges and then sample the data pin on a either rising or falling, I can't remember. And yeah, if you try to do that on the main processor, that's kind of tricky because the main processor's doing other things, could be talking to the disk drive, busy doing video. So it makes sense to shove the keyboard and mouse somewhere else, which is what IBM did.
Yep.
All the fans of Intel 8042 microcontrollers go wild because there is an 8042
in fact
on literally every PC ever made, because even modern chipsets still kind of have to emulate an 8042 keyboard controller.
And the 8042 also had this weird kind of interrupt, or I forgot what it was. There was something that was just really bizarre in the IBM PC where they used one of the spare registers in the 8042 for
Gate
enabling
820.
or dis.
It was actually like the 20th memory bit, so you could access a bit of a chunk of extra RAM. They're like, the keyboard controller has a spare I/O on it. Fine, we'll just wire that up to the RAM. So gate 820, you send a command to the keyboard to get access to like the bit above 1 megabyte. It's wild.
So yeah, and that's what all those crazy EMS and XMS drivers had to use, that to just really bizarre hoops had to be jumped through.
So I
kind of much like the architecture of the x86 was like that from the gate 820. The architecture of the 86 processors was like that from the get-go, with indexed addressing and was it the page and offset, and all the instructions, like you did your darndest to keep your code within one page, so you didn't have to do all the extra mathematics to manipulate the high word of your addressing. That was just weird stuff.
Imagine I could take you back to 1985 and you could relive your MS-DOS programming days, but I could give you a machine that was RISC with a 32-bit flat memory architecture.
Oh,
wouldn't that be nice?
It's a total game changer at that point. So there's the BMC. So it makes sense. The BMC gave us additional I/O and decoding and other important things.
There's an extra UART on there as well.
Right. So, and you've basically you've already got the software running on that, and to bring up the board, I'm going to have to program that chip first, right?
If you don't program that, no one's turning on the 5-volt power supply, because the reset control and the enable line for the 5-volt power supply are controlled by the BMC.
Right.
It's worth jumping out and having a look at the power supply page, because that took a bit of work actually.
So power supply is down here, and so we have our main input. Now I'm not gonna. So the jumper here is that for providing fan power, or it's just an auxiliary output I can take from the main jack?
It's an auxiliary output, or it's an auxiliary input. So in my case, I don't have a barrel jack on my DC power supply, but I do have some crock clips. So I can just feed 12 volts in there. So it's in front of the fuse.
And I like this. You've got some nice P-channel FET protection. I love those.
From someone.
I love those AOSMD. Alpha and Omega FETs are the best for this kind of job. They're nice parts and they're dirt cheap.
So do you know how I find the best parts? I go to my favorite PCB assembler manufacturer and I sort by quantity, because I figure if they've got $250,000 on a reel, they're probably shifting some.
Right.
Yeah.
If they've got 6, then that means nobody wants it.
Or everybody wants it. No, then it'd be 0. Yeah.
Yeah. But either way, like, it's also going to be reasonably low cost, or it should be, if it's a popular part.
And then I figured I may exceed the maximum gate voltage if you really push it. So then there's the Zener in there just to cap that at 5.6.
So I can see this DC on command comes from the BMC chip that you just mentioned. This is what's going to turn on our main PSU. This module, how did you find this? This is really decent. Like, it's a decent sized module.
It was browsing my favorite component supply from Thief River Falls, just searching for PSU modules, and that one seems to stand alone. There's nothing else like it I've seen on the market. It costs about $5. It's 5 volts, 3 amps, and it's a complete switch mode system with a control input, and you need 22 mic on the output, and that's your lot. 5 volt, 3 amps is beefy.
I've seen one that's even smaller that fits in a footprint almost the same size as a regular 7805 with
TO220 case. Yeah, and it's a whole switcher.
It's made by there's a few. TI makes some like that, but the one I've seen recently on a board I was working with, I think it was made by Murata.
Okay.
I don't know how expensive
Murata
they are.
makes good DC controllers. Yeah.
And
this one has a lot of pins. The symbol here. This is something where we could get into a debate about best practices. You've got a 5-pin symbol, but the actual part on the board has, I don't know, it's quite a few pins, like
9 or 10
pins or so, because I'm assuming they're doubling up for current.
Yes, if you double click on the symbol and then you go into the footprint viewer. So then I think,
well, look at alternate pin assignments. It's going to show us we've got one goes to, oh no, that's not really.
So if you go to the general tab, and then next to footprint, I think there's a, so in the table above, yeah, that one. So if you click on the little bookshelf.
Oh, it's going to open the library.
And that will.
It's not found. Why is that not found? But it's
because you didn't git checkout submodules. So when you did a git clone of the repo, the common parts are in a git submodule.
Oh,
so that's why that's missing. But you'll see that the footprint just has 3 1s, 2 2s.
Can I cross probe that on the board though? Because that should bring up the part on the board. If I go, is there a?
Yeah, you should just be able to. You may have to open the PCB from the main KiCad program, but then when you click on the symbol, it pans the PCB view around to the right part.
Okay.
So open, PCB view. And I think all the footprints just get embedded in the PCB. So even if you don't have the footprint library available, the PCB should just work fine. It
appears to. So I'm just bringing that onto the right screen. Nice job on the board layout, by the way. I know we reviewed this last time, but I will comment once again. It's very nicely done, and you've used a 4-layer board with unbroken planes.
Yeah, 2 solid ground planes.
And that is the best approach. That means the worst part of this for signal integrity is the through-hole connectors. And even there, your pinout of those is, we've got reasonable grounding, reasonably close by, and 5 volt. I mean, if I were doing it, I'd have spread the grounds out amongst. Well, you've got grounds referencing.
Yep.
Which the thing is, knowing that the board that plugs into this may only be 2-layer, and these are a long way apart, I may have put the ground between them instead of opposite them.
That's interesting. How next to may be closer than underneath, sort of depending on the kind of board you're looking at.
But this is certainly good enough. Like there were motherboards in the 90s that that were 4 layers, and they had similar things, and they were running signals up at with components.
We had to use techniques like parallel termination and stuff.
Yeah, and termination is going to be the other thing. So we could terminate on the last board or just past the last board. I mean, there's only if needed. I mean, once I get this running, I might hook it up to a 1 gigahertz scope and look at what the signals look like. They may be totally fine depending on what I plug into these.
So if we zoom in on the power supply, you'll see that it's got like 3 number 1 pins on it.
Yeah.
Do you have a ground test point?
So there's a 1, a 2, a 2, a 2, a 3, 3, and so the pin mapping's done just by numbering the pads in the footprint. And you can do that in Altium. I don't know about other tools. It's kind of the same model as Altium. You can make that happen.
So I guess that then you can get into philosophical questions about, should your symbols look like your package, or should they be more logically grouped? So for the Pico symbol, it doesn't look anything like the package. The IOs are on one side and the power's on the other.
Yeah, well, they have different purposes, you see. This is the physical implementation. The purpose of a symbol is to convey engineering reasoning behind why you're using that component and what it's being used for. It made more sense back when everything was analog and all the parts were discrete. There ain't no way you're building a hand-wired tube amp without a good schematic, and the schematic is understandable by the person who designed it, and it's understandable by the person who's wiring up the device in a factory, because they know what the lines and junctions mean. They don't need to know how it works or what it does, but it's different. You know, everything's a complicated device with many, many pins now. And this is, again, why some people argue, well, why even have a schematic? Well, I'll tell you why, because there's always going to be something discrete, something unique, and some additional engineering knowledge captured in the schematic that isn't captured anywhere else, and couldn't easily be. So anyway, I'll get off my
So just go back to that power supply module. The reason for that complicated arrangement of transistors is because the module has the enable pin, which must be grounded to disable the power supply. So I wanted that line pulled down if nothing else happened. So there is a pull down on it.
Gotcha.
Then you can push it high up to 12 volts to activate it. But 3.3 volts is not enough to activate the pin. It's got a threshold of about 4.5 volts. Hence why there's a couple of transistors to switch on 12 volts from the input.
Cool.
Actually, I think even the input voltage could then go above the threshold for the pin. Like the enable pin had a lower Vmax than the V-in pin. So I think that's why the D1302 is another Zener, just to try and cap that enable voltage to make sure I stay above V on, but lower than Vmax.
Gotcha. Yep. You've really done your homework on this. It's a nice design. So how do I bring it up? I'm getting antsy because we're at 57 minutes.
And you haven't even got the programmer out yet.
I want this to be alive. I want this to be alive.
So you are going to need to install the Rust programming language. And let's see if we can get your BMC programmed. You're on Windows, right?
Yeah.
Okay, this is going to be fun. Fire up a browser and go to rust-lang.org. So if this was a C project and I said, okay, now we're going to install your C compiler, you're going to need GCC. We're going to need a build system. So now you've got to go and install Cygwin and Make. And we're going to need to install OpenOCD and GDB. We'd be here all night.
Yeah.
I hope I can talk you through getting the Rust stuff installed much more quickly.
Okay, get started.
Get started.
Here we go.
Download Rust Up Init 64-bit.
Nice. So that's going to go into my. So I have into my NAS. I'm going to put it in the software engineering.
So this is the installer for a tool called Rust Up. And Rust Up is the program we use to manage our Rust installations. There's a new version of the compiler released every 6 weeks. So people regularly update their version of Rust to the latest one. It's not like GCC. We go, I've got GCC 7. It's 6 years old at this point, but whatever. I'm too scared to move from GCC 7 to GCC 8.
Going to run that?
Yep.
No, you fool.
Cargo Home is located at here.
Yep, that's just going to do a standard install. So just press 1 to proceed with installation.
I like this.
Do you have Visual Studio installed?
I do.
Yep, and it's detected that, because otherwise it would say, hey, you're on Windows, and sadly that does mean you need a C compiler and Windows compatible linker. Because you don't have Visual Studio installed, please go and get Visual Studio Community Edition, because it turns out Visual Studio Build Tools has weird licensing rules. But it's detected you have Visual Studio and it didn't ask you to go and fetch it.
That is also a time saver. So
it is sad you need a C compiler to make Rust work on Windows. I think it's really because you need the linker.
Okay,
because you need a Microsoft linker.
Okay, well, that's done.
The other thing you're going to need is a a tool called Zadig.
Where do I get that?
Have you it? So just Google for Zadig, Z-A-D-I-G. So in Windows, things like ST-Links can have 2 different drivers.
What?
USB driver installation made easy. So
okay.
by default, your ST-Link...
I've used this before. This might be installed.
So an ST will have an ST driver, and the open source tools don't know how to talk to the ST driver. They want to use libUSB. So what this tool does when you run it, you pick a USB device on your computer and you say, hey, stop using the standard driver and use this libUSB stub instead. Yep. It doesn't need any installation. You just download it and run it. That's an ad. I think you can just close that. Yes, download it in the background.
Okay. So just run this one.
Yeah, it'll want to run as admin, I think. Maybe it'll pop up a UAE dialog.
It did.
I heard a donk.
Yeah.
Waiting for my screen to come back, but I did hit yes. Here it goes. Do you want to allow Zadig to check for updates? So we're just running now?
Yep. So it looks like it hasn't found any USB devices or any computer. Is your ST-Link plugged in?
It is. Let me plug it in again.
Interesting. I wonder why that's not found. So ordinarily, Zadig will pop up and it'll say, hey, here are some USB devices. Which one do you want the driver to go away? Ah, there we go.
There it is.
Yeah, and you pick Win USB. That's it. And you click Upgrade Driver.
Now, to go back to the native ST-Link driver later.
Then you run the same program again, and next to Win USB, there's some little up and downy arrows.
Next, and I can...
there's some other, so yeah, you can go back to like...
Why didn't they make that a drop down? Come on, guys. Okay, all right.
So in the background, let's open up a terminal window.
Okay.
So yeah, Zadig will take a couple of minutes to run. But if you use OpenOCD, I think you need to use a similar tool. I think OpenOCD does the same thing.
I have seen something similar before. That's true. Putty, come on, Putty. Where are you? The Putty?
Oh, so no, we need a Windows command prompt. So we've got Windows Terminal installed.
I can tell you're a Mac user because you said Windows. Terminal. You said terminal.
Yeah.
Windows. Have you not got Windows Terminal installed? It's the new command prompt.
I do.
It's resizable and everything. It's amazing.
It's really nice. I like it.
I mean, Macs have had it for 20 years, but it's nice Microsoft finally caught up. I think they even support ANSI colors now. It's amazing.
Okay, so driver was installed successfully. So terminal.
So we're going to need to install some tools.
Wait, do we want to be in PowerShell or Command?
PowerShell will work fine.
Okay.
So if we type cargo, hopefully it's in your path. Sometimes Windows is funny and you need to restart to get... Hey, we're in the path. Yeah. So cargo is the build system. It's like make, but it's like make with bells on. It's a bit more like pip for Python. It can go and fetch packages on the internet.
Yep.
So the Flash tool we need is called probe run. It's made at the company where I work. So if you type cargo space install space probe-run, it will download all of the dependencies and compile the probe run binary. And that's all you need to do. That'll now just go in the background, fetch everything, compile it, and you'll have a copy of the probe run binary. What probe run will do is it's a combined Flash tool and logging tool. So it will look at all your USB devices. It will find your ST-Link. It will flash the ST chip on the board using the ST-Link. Then it will connect to it, and it will display some logs. So you can use it as like a logging stream all in one.
Good. So it will prove that that chip is functional at least.
Yep. That will show that you've got 12 volts going into the board and your micro power regulator is working correctly. you will need to either, so here's a question for you. You'll either need to put 12 volts into the barrel jack or the pin header, or you can back power the regulator. So do micro LDO regulators mind having 3.3 volts shoved in their output?
No, because they have, the worst case is they have body die that will go backwards towards the input pin.
Okay, so
I've
you just
never had they fall out of regulation and let go of the rail. So,
okay,
yeah,
cool. So if you've got a 3.3 volt output on your ST-Link, you could wire that to the header, and then you don't need the 12 volts. I recommend you don't do both.
No, I've got a 12 volt power supply here. It's no problem.
So I imagine if you did both, bad things would happen, because then you've got two 3.3 volt regulators pushing into each other.
Question is, are these internet pictures reliable? Because this is a standard ARM header. Is
that the header on the target PCB, or the header on the ST-Link? And it's like one of them flipped, or
I'm actually just it is keyed, so I can tell which is which, but I'm actually going to do one better and should have the actual ST-Link manual in PDF here somewhere. Just got to find it.
So for everyone playing along at home who doesn't have an ST-Link, I use a Raspberry Pi Pico loaded with some special firmware that basically gives it the same functionality as an ST-Link. It's it implements a generic ARM protocol, but like, you can buy an ST-Link, or you can buy a Pico for $4 and load it with free firmware.
I just happen to have the $30 ST-Link since it was a brand new product and there weren't any alternatives on the market at the time.
And to be clear, if you're a professional and you are billing your clients many hundreds of dollars an hour and you use a $4 board with free firmware, I have questions about your business practices. You know, if you're doing this for money, go and buy the real kit, because this board stopped working. And I wasted 2 hours of my personal time going, why is my programmer not working? You notice it has 2 sets of pins connected to it. So I got some pins down this end. This is what I used to use for programming. It turns out I've blown the GPIO pin on this microcontroller. Like, the IO pin is just dead.
This is another.
And that explains why I couldn't program it.
So I just
reprogrammed the firmware to use the other end.
Yeah, this is another difference I'll mention too. Like, the actual chip manufacturers and other higher end debug companies will give you things like isolated versions,
which is very useful if you're programming a mains powered device, because lots of mains powered devices, the 3.3 volt rail is at mains line voltage and the ground is 3 volts below that. So if you plug your programmer in, your programmer is now at mains line voltage. And if that's plugged into your laptop and your laptop is plugged into an earth power supply, you may have a small fire on your hands. So, and certainly touching anything metal will probably kill you. So yeah, mains powered stuff with microcontrollers in, you definitely want the good quality isolated versions. I also find using a Bluetooth keyboard and mouse, it's just extra bit of safety, just in case you've accidentally put the laptop at mains voltage. Especially if you're in Europe and you've got spicy.
Yeah, I was going to say, we're only half afraid here. Yeah.
Yeah.
Okay.
I've had mains voltage through my fingers. UK mains voltage. That was not a fun experience.
It really hurts. Yeah.
I had burn marks on the pads of my fingers where I was holding on to the shelf.
It really hurts a lot. Yeah, 230, 240. It's nasty. Okay, so I've got my pin one.
So does it say in the manual which one is SWD and which one is SWIO?
Yes, it does right here. So ST-Link V2.
In classic ST format, they've given you a table, but not necessarily a nice diagram. Like a diagram with some colors, I think would have gone a long way here.
I need pin 9 is SW clock. And note that they put ground between them.
Yep.
And let's check the pin numbering.
Oh, that's because it's for IDC.
Staggered numbering, right? So I think they're pretty much all ground on this side. Even numbers are ground. 1,
okay,
2,
which
3,
is what
4,
I did.
5, 6, 7, 8, 9. So 9 is right by the key. So sorry, folks, this is the slow part.
This is embedded programming. How's your probe run build doing in the background? Has that finished yet? Or has it died with don't have
library?
It finished.
No, it downloaded all the dependencies automatically. You didn't have to install a thing, as I expected.
Yep. So I need SWDIO.
Yep.
Which is pin 7. 1, 2, 3, 4, 5, 6, 7. So that's my red wire. Actually, we need the target VCC. I think we do.
So it depends on the programmer. Sometimes programmers want to know what VCC the micro is at. So
yeah, so red, I'm going to make the target VCC.
So that's going to take 3.3 volts out of the board, and it's going to set the internal level shifters in the ST link to be 3.3 volts. Another reason not to use a $4 Pico, because this is 3.3 volts come what may. If you're programming a 1.8 volt chip, you're going to have a bad time.
I'm going to use a
proper programmer with level shifters in it.
I'm going to use brown for ground because that's right next to the VCC on my jumper wires. And
I guess black would be traditional, but sure, go for brown for earth. Why not?
Well,
it's live in my country.
Right, just because it's right next. Anyway, so I need pin 1, 2, 3, 4, 5, 6, 7, which is yellow, is going to be SWDIO. Pin, then I've got pin 8 is ground. Pin 9, which is orange, is SW clock. And then we need reset. N reset is pin 15.
You don't need reset. You can reset using SWD. It's on the board. You don't need it wired up.
So now here's where I'm getting confusing. So we have SWDIO, but further down, TDO pin 13 on the table says SWO.
Yeah, that's serial wire output. That is another alternative logging stream format. That's basically a 2 megabit UART. We're not using that, so you don't need SWO.
Good to know. So I have VCC clock, SWD. So I don't need the reset pin.
Nope.
Does it hurt to connect N reset to N reset on the board?
I don't know. I've never tried to connect it. I know it works without it.
Okay. Well,
you're welcome to go off piste for the purpose of drama in the live stream.
Well, I'll just leave it floating, or I'll attach the other wires to ground, just so we have more grounds nearby.
I feel at this point there should be like a voiceover, like Ben has decided to connect the reset line, even though the instructor said that wasn't specifically required. Foreshadowing later on, Ben pulling his hair out. That doesn't work. Close in zoom up shot of the reset line. They told you not to wire in.
Okay, so yellow is...
There's not enough embedded stuff on TV. There should be like a Great British Bake Off, but for embedded
controllers. Yeah,
just a bunch of people in a shed with a pile of scrap. They're like, today you need to make a functioning washing machine controller.
Well, actually, that's kind of like the show Joe Grand got famous on, was Prototype This on Discovery Channel.
Okay.
And it was
cool. I'm gonna have to check that out.
It was a wonderful show. Okay, so red's going to 3v3. Brown, black, and white are all ground, so I'll just hit brown to the ground here. And there's some other grounds on a nearby header. I'll just connect to one of those with the black. And then I've got yellow as SWDIO. So that's going to SWD, and then the clock is pin 9. That's orange, so it's going to the clock pin on the BMC header.
I'm starting to feel I should have given you an ARM 20-pin header. They just take up so much board space. I only need 5 pins. I'll just put the 5 pins down.
Yeah. No,
and I've done what you've done. I've got what is that, like 4 inches of cable? So now my programmer can only be 4 inches away from my PCB. But my programmer, the one I actually use for the ST, it's got a USB-A plug on it, like a flash stick. So now my USB hub can only be 4 inches away from my PCB. It's all just getting a bit tight.
Right. So how do I make the board the main thing again, Bill?
How do you do what? Drag and drop, wasn't it?
Drag and drop ain't working for me.
Oh, you want to show the main board as a solo like that?
Yeah, yeah. How did you, or as the main in this view, switch the screen share with the board?
Yeah, it's not working, is it? Hang on.
Can you do it with the screen share open?
We could do both side by side because I'm probably about to run some commands in here. So I'm pretty much ready to power it up and try and program this chip.
Okay, so we're going to need to check out some firmware. So have you got, I assume you've got Git installed?
I do. Let me bring up another window here and go to, actually, there's a faster way to get to it.
You've got like a special place. Everyone has a special place on their hard disk where they do all the Git checkouts.
I'm a glutton for overusing expensive cloud storage because everything I check out of Git is also on my own Dropbox.
Ah, interesting. I deliberately do the opposite. Everything I check out from Git, I'm very careful to not put in my OneDrive because I'm like, it's on GitHub. I don't need Microsoft uploading it all to OneDrive and chewing all of my
I know
all of my storage space.
I know. I've got to find a better system, but the reason I do this is because I want to just synchronize between different computers automatically without having to think about it.
Right, without having to like push and pull Git branches.
Right, so these are all the repos I've currently got. I'm probably going to have to go and clean some of this up, but
you've got the Neotron PICO, which is the hardware file. Yeah, we're going to need the BMC firmware. So we're going to need, I can give you the URL off the top of my head. I've typed it often enough.
Yep.
So git clone.
Yep.
If you've got keys, you can do git at GitHub. If you're not, you can do HTTPS. That's fine. It's open source. GitHub.com.
Yep.
/Neotron -compute. We really struggled to find an organization with the word Neotron in it that hadn't already been taken, and that's the one we ended up with. I don't like it, but it was free.
I like
/
yeah, that's not
Neotron -BMC.
Yep, just that.
.git.
Oh, yeah.
I think the .git is optional. It works it out. It goes, hey, you probably don't want the web page. We'll give you the Git repository instead. Okay.
Yep.
So we'll go into that folder, and then there's a couple of things going on in here. There's a couple of library. It's Neotron BMC.
All right.
So there's the firmware builds for 2 different boards. It builds for a Nucleo as well. So we need to go into the Neotron BMC PICO folder.
Yep.
And there's also libraries for the command protocol it speaks because they need to be shared with the main processor. Now, if we try to cargo build, it would fail because we haven't told it about ARM chips yet. It's gone, you're on an Intel PC with Windows, so I've only installed the libraries.
Oh, I gotcha.
So isn't this a pain on ARM for C? We'd be going to get ARM GCC embedded, and we'd have a whole separate C compiler for ARM as opposed to for Windows.
So what do I do now?
Instead, we're gonna use the word rust up. So we're gonna run rust up target add ADD.
Oh, add. Sorry.
Yep. And then the target name is thumb v6m.
Oh yeah.
Dash none, because there's no operating system, no vendor.
Yep.
Dash EABI, the extended ARM binary interface.
I was waiting for that.
So when you press enter, that will now download the precompiled standard libraries for the thumb v6 architecture. Wasn't that simple? If you type rust up target list, we'll just have a quick look at the other targets the things you could have won.
Oh, look at that. It's glorious.
Would you like to do some RISC-V? Would you like to do some Spark v9 for Sun Solaris? Would you like to do some Linux on MIPS?
Heck,
all of these things are available to you with a single Rust up
all the
target
ARM
ad.
families.
Rust
Lovely.
is the cross compiler out of the box.
Love it. Brilliant.
If I said, hey, go and find me GCC for MIPS on Linux, it's just going to take you a while to fetch it and install it. It's all here.
I love it.
Now we can run the cargo build command. So cargo build, and we're going to add /release. Because if we don't build it in release mode, it doesn't fit in the firmware.
Right, gotcha.
That's it.
That's something that bites me with every embedded project. If I stay in debug mode, there's very little I can do before I'm forced to go and start using. It's like I can't interactively debug this anymore because the debugger is taking up too much space.
Right.
It's a big pain in the butt with small micros, particularly STM8. I recently had that. It's like we ended up. I didn't write the code, but I modified it for this customer, and another friend of mine did the initial code. And he actually, right from the get-go, was doing printf debugging with the UART because it was the only way to do basic debugging without taking up the whole flash. Okay, so what happened there? There was a problem.
I think that's because Dropbox was touching files in the background while the compiler was trying to use them. And on Windows, you can't open the same file twice in two different programs. So we may just have to run. Sorry, there's one more thing you have to install. Cargo install FlipLink. So FlipLink's a fun thing. It is a special linker that was written at my company, Ferris Systems. I'll give them a plug. What this linker does is it links your program normally, in the normal way, where stack is at the top and global variables are at the bottom of RAM, and global stack descends towards your global variables. What FlipLink does is it links it once and it looks at how much memory you're using and says, hey, you've got 1K of global variables and all of the rest is stack. I'm now going to write you a custom linker file that flips that upside down so that now the stack's at the bottom and the global variables are right up at the top.
Oh,
good news.
AVG didn't like.
And what this means is when you run out of stack space, instead of crashing into your global variables and causing a mess, you go below the address 2 and 7 zeros, which is the start of SRAM, which is a hard fault. So now a stack overflow will crash your chip instead of silently trashing it and then carrying along like a zombie.
So this finished in This finished in 2 lines. Am I to believe it? Because
because everything was already pre-compiled because you compiled it above. So yeah.
And so the error above wasn't really a comparative.
Yeah,
it's just trying to delete some temporary thing.
Oh, okay. So you were uploading it to Dropbox when it was cleaning up after.
Most likely, yeah.
So now to run the Flash tool, we type cargo run /release. And cargo run has been configured on this system to call probe run, which I haven't even told it you have an ST link. It should just find it, flash the chip.
Look at that. It found the chip. That's the actual chip part name. It might have been AVG getting in the way as well before.
Is your board powered on with 12 volts right now?
Oh, no.
Because I can't see anything in the Darrell jack.
It isn't. It isn't. Look.
That'll be why the probe had a problem talking to your microcontroller.
Let's try this.
Unfortunately, we can't report. Microcontroller seems to be turned off, but
okay. What else am I missing?
So let's try probe run space /list-probes. So let's just check it can find the ST link, and I think it can. Yeah, yep, so it's found the ST link. So at this point, honestly, I suspect a wiring error. This is normally the kind of issue you get when SWDIO and SWD clock are not wired correctly.
Okay, let's do this. I'll try this again. So going back to my PDF. Back to the PDF. And just double check
So we think 1 is top right. So
Pin
to
1
the right of the
is
notch.
at this end. So this is upside down compared to what's here. You see the key is at the bottom.
Yeah, good work, ST.
Right. So pin 1. And then I'm going to go the opposite way. I'm going to start on the board because you've got beautiful labeled silkscreen. So yellow is 3.3 volt.
Yep.
Right next to that is orange, which is clock.
Oh, it's resistor colored IDC ribbon. How nice.
This one is, yeah, it was one of the ribbons that came with my a bag of USB UARTs. SWD is red. That's next. Reset is brown. That's next. Maybe because it does need reset actually, and ground is black.
Yeah, maybe the ST Link does need reset, and it's something the CM-SysDAP can do without, but maybe the ST Link can't.
Right. So, so on the ST Link, I've got pin 1 is target VCC, which is yellow. That's the first one. Then I've got the clock is on SW clock is on pin 9. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9.
1, 3, 5, 7, 9 along the top.
1, 3, 5, 7, 9. Yep. And then SWIO is pin 7, which is one up from there on the same
just
side.
Inside, yeah. So that should be VAP, 2 empties, IO, and then clock.
Totally got that. Yep. Then reset is brown, so that's pin 15. So 9, 11, 13, 15.
So this is where the producer inserts the flashback back to where the instructor said the reset pin's not required.
Yeah.
Turns out the foreshadowing was all backwards.
And then the other 2 wires I'm just hooking up to grounds. Okay. So we're hooked up. Let's minimize that. You can see in the picture we're hooked up. There's no other resets or anything I have to hit here first,
Nope.
right?
Nope.
Okay. So let's try this.
Let's run it again. JTAG.
An error specific to a probe type error occurred. JTAG get ID code error. It's trying to use JTAG, but we're using SWD. They're different protocols.
Yeah.
I think that might be what the problem is. How do I tell the ST Link we want to use SWD and not JTAG? Let's have a look.
So someone has raised an issue on the probe run issue tracker, reporting exactly the same error. Someone says, I had this error message pop up once. The fix was just resetting the device. The poster is completely non-specific, whether they meant the ST Link or the board.
Well, I'll do both.
Yeah. Turn it off, turn it on again.
I'll power the board first and then the ST Link. And then, what could I have done wrong here? Okay, at this point is normally where I get a meter out and actually probe some power supply jumpers to make sure we do actually have voltage. So I'm going to go grab a meter.
Yeah, worth checking. You've got 3.3 volt. So there are 2 3.3 volt regulators. One is chained off the 5 volt switch mode. That's a chunky 1117 1 amp type thing. And the other is a micro power regulator, which takes the 12 volts and drops it down to 3.3. So it's dropping a huge voltage, but it's only rated for 50 milliamps. It's like a tiny thing. And that's what keeps the BMC running in the background, even when the power is switched off.
Really good low standby power. Okay.
Some of the other beta people in the channel were asking me, hey, what kind of power supply should I get? Should I get like a 2 amp or a 3 amp 12 volt supply? And I said, well, I hooked mine up to my bench supply and it was drawing 50 milliamps. So, I mean, basically,
2 amps then.
Yeah. the reason it's a 3-amp power supply is because originally the board was going to have 4 USB ports on it, and they need to be half an amp each.
Right.
So that's why I spec'd a really chunky 5-volt supply. And now there's no USB on the board, but I'm like, I've already designed the power supply. I'll just leave it. It only costs $4.
So it looks like I'm only getting 1.3 volts out of this. That's
what's your 12-volt look like?
That's what I was trying to look at. So from the adapter itself, I'm not getting anything. Oh, it's got this stupid little switch. How about that? Might help to turn it on. Oh, come on. It's always something asinine. Honestly, who puts an inline switch on a 12-volt?
So I'm the opposite. I really wish I had a 12-volt inline on my power supply, because I'm forever having to pull the barrel out.
Okay. Yeah, but once you've got a BMC, you don't need it, because the BMC will do the on-off.
Yeah, but I'm programming the BMC. That's my problem.
Yeah, see?
Hey, there we go.
Might help to have power.
Cool. So there's something we can do that we haven't done. So if we press Control-C, so basically we built it.
Look at this, power LEDs flashing now. Yep. Okay,
so
what?
If we press Control-C to exit out of this, I want to rebuild the firmware, but with some logging turned on, so we can see some messages going on. So if we exit out, and now we need to set an environment variable. And I think in PowerShell, this is weird, right? You have to say $env :
Oh, that's
variable, mate. Because PowerShell environment variables are just weird.
Can I do it? Can I cheat and do it this way?
Probably. So the environment variable is all in capital letters. DEFMT.
Is that correct?
FMT for format.
Yep.
Deferred formatting. Underscore. Log. Equals.
Yep.
And let's say info, which should be in lowercase. Info, I think, should be in lowercase. Yep, there we go. Try that.
Just check that it's in there. I've got a lot of environment variables. It's in there.
I think it's there. Okay. So
I'm back to PowerShell.
So now the question is, does PowerShell still have the environment variable? Let's run cargo run and see if it recompiles some stuff.
I can see.
Yeah, no, PowerShell just doesn't work like command. So
dang it.
PowerShell is one of those weird things where you can almost pretend it's like command, except for times like this when it's completely alien. If we run the cargo run again, we should see it recompile some things if it's found the environment variable. And look at that. You mistyped a command and it went, hey, did you mean this other one instead?
I like that.
Yeah, no. So the environment variable hasn't been set. I think you have to do it inside PowerShell.
Okay. Yeah.
So $env : that's not a dollar.
Oh. No, it's a pound. That's your dollar.
That's a hash. So there's no space after the colon, and then it's deformat underscore log equals info. Equals, not dash.
Oh, fat fingers.
So PowerShell does at least colorize the things as you type them.
I do like
which
that.
Is kind of nice. How do you set environment variables?
Wait.
All the people in the people on YouTube are just going to be shouting at the screen.
Yeah,
I know.
No, you.
I think most people who watch our streams are not Windows PowerShell.
There should be spaces either side of the equals.
No.
Oh, and it needs to be in quotes because it's a string.
Oh my gosh.
PowerShell is the future. Oh, it's gone blue. The blue's better. Okay. Now run cargo run. And it will recompile it, but this time the logging will be enabled. It defaults to logging as worn, so you can't see anything. But what I want to show you is this tool is really cool because it doesn't just flash it. It then opens up a real-time logging stream, which is actually super efficient because all the processor has to do is store a pointer in a special buffer in RAM, and the debugger in the background is peering into RAM and going, hey, somebody put some new logging in. I'm going to read it out of the log stream, and the processor is carrying on and doing something else.
Now I see what's happening.
When you do debugging, the processor has to stop while the logging messages is printed over UART, which takes an eternity.
Yeah.
Here, the logging message goes into RAM, and then the processor carries on, and the debugger fetches it out of RAM, which is really neat. And you can do it in C. It's just a real pain to set up. And here it's all built in.
And what I'm looking at there, it looks like little tiny snippets of Rust. Neotron BMC Pico, :app, :init. Is that?
Yep. Because whenever a log message is emitted, it's telling you which module, which file and line number generated the log message.
Oh, that is so cool. So my BMC is running.
Press the power button.
Power button released.
Now you should have 5 volts, and the power light should have gone solid.
So the flash, it's solid, and the flashing meant it was on standby.
Yep. So now if you hold the button, if you tap it, nothing happens. You have to hold it like a PC, and now the 5 volts gone away.
Cool. And we talked about it. It's also controlling reset to everything else, right?
Yep.
So now what I can do is plug in the USB to the Pi Pico, and if I put a jumper on, boot 0 over here,
no. So boot 0 is to put the ST into UART bootloader mode. You want to hold the button on your Pico, and so there's
that's right.
There's a specific order to do this in. Yeah. So
boot select.
You want to have your board in standby.
Yep.
With the USB unplugged, right, and you don't want any USB on your Pico because that will power it. We want it unpowered.
Okay.
Hold the boot button.
Yep.
Tap the on/off button on the board.
Yep. The power's on.
So that will now boot your Pico in bootloader mode.
Yep.
Now you can let go of the bootloader button.
Yep. Plug in
now
USB.
You can plug it into your PC with USB.
And sure enough, it shows up as RPi-RP2, and I can download firmware to it.
Yep.
Awesome. That is cool. So at this point, is there a firmware I could drag and drop on this in the?
We would build it in the same way as the Pico firmware, actually.
Okay, so walk me through that real quick.
Okay, so we're going to need another terminal. We're going to do another Git checkout.
Yeah, well, I'll do it in this one. So let's go to. Yeah, screw it.
Let's make another folder called temp. That's what we all do. Just random folders called temp all over the drive.
Well, I want to go to it's actually E drive where I have GitHub's here. So I'm just going to go here and go right click, open in terminal.
So we're going to do another Git clone.
Yep.
https://github.com/neotron-compute. /neotron-pico-bios. I try and give my Git repository sensible names.
Love it. Git.
Yep.
Okay, there we are. So I'm going to
go into that folder. So cargo build /release. So what we could do at this point is we could probably move your ST link over onto the Pico, but given all the trouble we had wiring it up, let's leave the ST link alone and let's do this one over USB.
Yep. Wait, you can use an ST link for a Raspberry Pi?
Yeah, I'm pretty sure. I think you can. I know the CMC stat ones will just program anything.
Right, but they're from ARM. They're like These will work on all our processors.
The ST-Link is just speaking SWD, so I expect SWD to be the same on any microcontroller because that's an ARM standard. I don't think ST-ified it.
Right. Gotcha.
Again, folks, if you're doing this professionally, buy the right tool for the right chip. Don't just try and plug any random programmer into any random chip. If you're doing this on fun time, give it a go. Why not? It's probably not going to blow anything up.
Well, this is it's chugging
downloading
away.
and building in the background. If you call up Task Manager, you'll see it's spinning up all of your CPUs at the same time because it's a multi-threaded build.
This is not to be a real problem because it's just trying to remove temporary files, and I don't care about that.
To the background. So one thing you can say that's bad about Rust is the build folder is a folder called target. It's quite big. Like I regularly have target folders that are like 10 gigabytes in size.
Yikes.
Because I keep rebuilding it. It doesn't do a good job of cleaning out the old stuff. Okay, so now we have an ELF, a standard binary, and we need to make a UF2, which is the Raspberry Pi format. Actually, it's a Microsoft format for programming. So there's another tool we can install, cargo install. ELF to UF2. ELF to UF2 with a digit 2. That's it. I think that's the name of it. Let's see if that works. If not, it might have a -RS on the end. Try it again with a -RS on the end. People like adding -RS to their repositories.
Why -RS? What does that mean?
Oh, because that's the source code file extension for a Rust source file, .rs.
Got it.
Lots of domain names in whatever country is .rs as well. Someone's posted me in my little side chat. They think the ST-Link V3 has been nobbled, so it only does ST chips. It probably like reads the manufacturer and like vendor and product ID out first and goes, nah, not going to play today. It wouldn't surprise me.
Following packages contain code that will be rejected by a future version of Rust.
Yeah, that doesn't matter.
Okay, so now do I need to build that tool then? In that case,
no, that is built and installed ELF.
Oh, it's so it's an exe. So now I just run it ELF to UF2.
If you just run it like that, it probably. I don't think you need. Oh, you do need the RS. Yeah,
I do because the exe
run that
file,
as it is.
Yeah.
Just press enter, and it'll tell you some help text. I think.
Bloody AVG.
Oh, excellent. Okay, so we just need to give it, I think it's the -D argument, which will tell it, find a mounted Pico drive and copy the file to it. So that'll save us some work. Yeah, -D for deploy.
Yep.
And then the file we need to give it is in /target. That's the build folder. You're on Windows, your slashes go the other way.
Yeah.
Those ones probably work actually.
I don't know. Yep.
/ and then the target name, which was thumb v6m none ERB. The tab complete might work.
Yeah.
Hey, save you some typing. Neotron PICO BIOS with dashes. Oh, actually, sorry. No, the next thing is release. I forgot release because we did a release binary. And then just hit tab. Is that going to tab complete? Yeah, there we go. Enter. Done.
Oh, that actually disconnected the USB to the Pi.
Yep, because it's been flashed and rebooted. So if you have a VGA monitor, you should have some VGA out on your Pico.
Even right now?
Yeah. Yeah, it's booted.
Well, let's get this going then. In that case,
you've got a fancy VGA capture. I don't have a VGA capture device. What I have is a VGA to HDMI converter and then an HDMI capture device, which is all kinds of messy.
Let's go extra camera, and it's going to be USB 3 capture. It may not be powered enough. Let's try it. Let's power. If I power off and on, even without USB, this should work, right?
Yeah, it should be fun. There we go.
There it is. Yeah.
There's a picture.
How do we make that? Oh, it disappeared.
Okay. So you have one of our experimental early versions, which contains a bug. So like a standard PC, it boots the BIOS first and then jumps to the operating system.
All right, but there is no OS.
Yeah, well, the release, the first thing the OS does makes the OS crash. Actually, the second thing the OS does makes it crash. The first thing it does is clear the screen. So there are some experimental branches. It's probably too much detail to get into now. We can talk about it in the Matrix chat. We have a Matrix chat for this project. Search on Matrix for Neotron, and you'll find the chat room where we talk about this. And so, yeah, there's some fixes, but we definitely saw a picture. So for the first 5 seconds, there it is.
If I hit reset, it shows up again.
Yes.
Reset on the BMC.
Nice. It takes about 4 seconds for your capture card to lock onto the picture. Yeah, so there we go. Everything is working. Now, if we'd sat down and done this as a C++ project, do you think you could have just installed the tools?
No freaking way.
Installed everything.
No way.
Isn't Rust embedded good?
Even if I was doing FreeRTOS and all this firmware like the BMC BIOS and all that, like we had, was all there ready to go on GitHub, like it is. And we would say doing C++ and FreeRTOS. There's no way we could do this in less than 2 hours.
So my embedded training course, we don't require you to install Rust before you come on it, because we'll just talk you through it. It's the first 10 minutes of the lesson is installing Rust and all the programming tools.
So that course, do we have a link to that, or
so the website is ferrous-systems. Ferrous as in things going rusty, as in ferrous metals. Nice. Yeah. So ferrous-systems.com, and then we do Rust training, embedded trainings, and all the trainings are open source. So if you go through the website, you'll find our GitHub, and so you can do the Ferrous Systems embedded training course by yourself if you want. It's just a little workbook.
Tell me if this is correct or not.
That's the one.
Okay, that's where they can find you and your Rust.
Yep. So we make all of our trainings open source, and if you want someone to talk you through it, we can do that as well.
That is lovely.
Isn't it nice to know there's a better way to do embedded software? I watched Dave and the two from the Amp Hour.
Yeah, Dave and Chris.
Dave and Chris. Yeah, I'm sure I've heard them talking about firmware, and Dave had some firmware for one of his projects, and his engineer had written it in modern C++, and Dave had to go and install Meson, and then he had to go and install GDB, and he had to go and install something else. And I remember complaining, like, "Hey, I just like Arduino, right? Because I just load the code and hit program, and it works." So this, I mean, it's not as simple as an Arduino, but
this is better though.
You've never done it before, and all you had to do was type in some commands I could have sent you by email.
I do have to ask this.
Power your board on.
I do have to ask this. So we've streamed really long today, which it's a nice chunky stream, but the key concern with Arduino and why a lot of professionals won't use it, even though it's hyper productive, right? Because of that, you can just try something, bam, try it, bam. The concern is you're using spaghetti code written by random strangers under all sorts of different licenses, and
you have right there in the text, no warranty given or implied.
Yeah, you just can't. So with Rust, is it the same kind of deal because it's open source, or like how does this play with the concept of doing commercial work for profit?
So every crate with Arduino, you like go and grab random packages and drop them onto your hard disk. Here, the software's all been downloaded from a central repository, and there are cargo commands we can run which will tell you the license of every single thing you just built. So then you can just ship the licenses with the binary and or send them to your lawyers for review. And you can search and go, hey, am I building anything GPL? No, cool. It's all MIT and Apache 2. So if you type, I think the command is cargo tree in the terminal window, that'll show you the tree of all the packages. So all of the dependencies, and then their dependencies, their dependencies. And there are other cargo commands you can get. Maybe option like cargo license is one, which goes through the tree and just gives you the license text. But each of these packages has been published and has a license with it, and it could not have been published without a license.
Woo,
so they were required to give you a copyright statement and a license statement with every package. So I think it's, that you get into these discussions like with JavaScript, all the packages are tiny because packages are easy. And so my project now has like 50 million dependencies. C, dependencies are a nightmare. Nobody has any dependencies. You just copy and paste the source code from project to project. Rust is somewhere in the middle. We have dependencies. We try and make them at least understandable. Cargo license, I think, is an add-on that you
I'm gonna have
cargo
to
install cargo-license. You can install cargo plugins. It's normally in a project called cargo-something. This will just take a few seconds to build, and then you can run cargo license, and it will give you the licenses for everything you've just built.
Okay, well, that's cool.
And there's other tools. So again, building professionally, I don't recommend you pull random packages off GitHub because people do upgrades, and sometimes their upgrades don't work. So there's a tool called Cargo Vendor, which will grab all of the source code and put it on disk. Like all of the dependencies just get placed on disk. And like, cool, now I'm going to zip that and keep that. So now I can come back and do the same build in 6 months' time. When my client calls me up and says, hey, I want version 1.0.1, exactly the same as you gave me last time, but with one bug fix. You need to have vended your source code because otherwise you do a new build on a new day and you get new versions of everything and maybe something is subtly broken.
Oh,
hey, thanks,
my
AVG.
gosh. Everything I'm trying to run from command line gets halted by AVG. It's so aggressive right now. I know it's going to come back, but why does it have to take so long?
Wow.
So then it stops it, but then it reruns it. And there it goes.
So there we go. So that's the licenses of everything you just built.
I love it. Apache 2, BSD or MIT, BSD. What's CCO?
Creative Commons 0. So that's basically public domain.
That's okay too. I'm good with that. GPL 3 or later, there's a few.
That's my 2. So, and for very good reasons. My BIOS is GPL'd because I want to make sure everyone who gets the board is guaranteed a copy of the software. I don't want some
that's fair.
Bulgarian manufacturer shipping boards with the BIOS on and not giving people the source code. I made it so they legally have to do that. My SD card driver, I didn't bother. The SD card driver, fine. That's MIT. Anyone can have that. But the BIOS, you should get the source code for your BIOS because this is the point of the project. It is an open system. You get the schematics, you get the PCB layout, you get all the firmware top to bottom. You should be able to understand this computer in its entirety.
Yeah, I love it.
That's the point.
That is very cool. Wow. And we're nearly 2 hours in. I'm actually going to have to drop.
But well done to everyone who's still streaming with us. It's good effort.
Oh, this is brilliant. Brilliant. You've done such a great
People shouting
job.
at us, turn it on.
Yeah. Yeah. It's on. It's on. We've seen
it's running.
It's working.
Does
now
exactly what I expected to do.
Now
just wait for me to type some newer firmware.
Yeah, and now I've got the whole system up to date. So whenever you let us know you've done an update, I'm on Matrix as well on your channel on Matrix there. But whenever you release something, I'll know what to do to get it.
Press up, enter, you're done.
Yep. And next thing, maybe design some add-on boards for this thing.
Yeah.
So that was the other thing that was shipped in the box that you sent me for this beta was this is the template. I'll just show it on the camera there. The template add-on board. I could make
you got a purple one. I
could make this much longer. But yeah, the idea is this goes in here, and it would actually fit if I had a bracket, AT enclosure. PC
yes, that's
AT
the idea. The end bracket you probably need to 3D print. Did you just hot plug the card while it was switched on?
There's nothing in the card.
So yeah, it should be fine.
There's no load. There's nothing on it. And as far as I know, nothing's recording things out.
Yeah, it's not like EISA where the pins cross each other, right? The pins are just straight down. So yeah, mechanically that's fine. Just go straight in.
So and get some other things going. Yeah, this is going to be cool and fun to play with. And it gave me the other idea too, that you could do a newer version of this as a backplane type thing, and we could even do things in future like turn this into an actual kind of documented standard that people could follow, and then you could have this whole Neotron, the exact same thing, but on one of these cards.
Yes, like you get with them. They took the PCAT standard and they made it just a flat black plane where the PC was in a card.
Yeah.
And then you put expansion cards next to it. Yeah, so there's lots of standards for hardware. There's Raspberry Pi hats, there's Arduino shields, there's Digilant have their PMod, Olimex have their UEXT. There's a bunch, but none of them seem suitable for expansion cards. They're all pin headers. And I didn't want to put my cards in with pin headers because it should be a card like an Apple II, just chunk in the slot.
I much prefer card edge connectors over stacking pin headers. I can't stand stacking pin headers.
How much do you think those Amphenol card edge connectors cost? There's 4 of them.
I have no idea. They can't be too expensive.
60 cents.
I paid £2 each.
Wow.
£2 each? Ouch.
You have £8 of. That's how much I love card edge. You have 8 quid's worth of card edge.
There are much cheaper ones, you know.
Yeah, but again, as a software engineer, you're just looking at one of the big catalog vendors, like our friends in before. These and you're like, I don't know what any of these do. That
I can tell just by looking at these that they're the high quality
gold.
Glass. They're glass fiber filled and they have gold plated contacts. They're not your cheap knockoff.
If you can find me one that's got the same pitch underneath and takes the same cards.
Yeah, well, like Drew Dastardly says, you know, dirt cheap on AliExpress. You could get
which is where the keyboard connector came from. So your lovely purple and green PS2 connector. That's an AliExpress special because it turns out the pin out is kind of standardized. So I have some expensive ones from your catalog supplier, and the AliExpress ones were a drop-in replacement, and they were about 20 cents each.
How many did you make of this board in your last run?
So this production run, I said 25. I actually got JLC to build 30.
Okay.
I only had parts to build 30 because as JLC got the parts in stock, I would use their part ordering process to reserve them. So I only had 30 codecs and 30 STM32s, and so that's it. I'm now all out of parts at JLC, and I'm all out of money. Shout out to the Rust Foundation, who support the Rust programming language and gave me some money to make these boards, which is how you were able to get one for free.
I really, really appreciate that. And my gratitude goes out to the Rust Foundation as well. And it's
because they want you to experience this. They want you to see what a joy it is to do embedded programming. And without a board, you can't enjoy this. So.
Oh, this is freaking awesome. And I'm looking forward to inventing some new stuff just with this as a platform. And I want to support this project as well and encourage everyone. I don't know how you could do this, Jonathan, but maybe you should consider a crowdfunding or some kind of campaign. You can actually partner with JLC again to do some assembly and have them drop shipped or whatever. But people need this. This is cool.
Cool. Yeah, if there's interest, we can definitely look into something like that. But I'm not sure I want to spend the rest of my life trying to put 5 electrolytic caps in a bag and then make sure everybody gets exactly one SD card slot.
It's got to be all done by the main supplier.
There's got to be places who can do those kind of kits.
Absolutely,
for you.
that they will. It's just a matter of getting. Yeah, it's a matter of communication and telling them what you want. They'll make it happen. They can all do it.
Because that was a good solid day of making 25 kits.
Yeah.
And I got really good at wrapping Christmas presents because everyone came in wrapped in brown paper.
Yep. I did like that. That was a nice touch.
Cool. And again, those cardboard boxes, they arrive flat pack. You just assemble yourself a nice little cardboard box.
Yeah.
So I've learned loads about packing materials in the last couple of weeks, more than I ever wanted to know.
Well, once you get this to a level, you can train someone to do it for you.
That's a good idea. Right.
Thank you so much, and
thank you.
See you again. And you put some really great work into this, and I'm looking forward to getting more things going on it, and maybe playing some retro games ported to a dual core ARM Cortex M0 Plus, and but more than just games, doing some other. This would be a really neat platform for all sorts of industrial control applications as well. So, I mean, but flip, I mean, it's more powerful than a 1990-91 desktop.
Oh, for sure. Yeah.
That means it's perfectly adequate even for word processing if it came down to it.
Yeah. Full screen text editors on my list.
Yeah. So cool. Well, thank you so much. And
no worries. Yeah, happy holidays, Merry Christmas, and all that. And
yes,
enjoy.
Same to you. Same to you. And by the way, I'm loving the winter coat.
Actually, my beard trim is broken. It's on the list of things to be disassembled. but I'm enjoying it in the meantime.
It's looking good. Enjoy it while you got. Yeah, maybe
enjoy it before it turns gray. Yeah.
Yeah, it's a little bit coming in there.
Yeah. Cool. And now, Kersa mentions this is a good topic for a future stream. Again, probably, Jonathan, we could invite you back maybe in another few months, and we'll talk about this. Let's do some performance tests or benchmarking of Rust versus other. That would require a lot more work to pull off, but we could probably prepare something and make it happen.
Do a bit more. And to be fair, in case anyone thinks there's smoke and mirrors going on, I think there was zero prep here.
There was zero prep.
I don't think you did any prep. This is just.
I did none. The only prep I did was to solder the through-hole parts onto the board from the kit you sent me. That was it.
Because that's the bit on YouTube everyone does on fast forward, right?
Yep.
Nobody watches soldering in real time. That's not,
and you already did that on your stream to introduce people who, like me, who were getting the board. This is what you need to do when you get it. So and that's still there on your channel. If anyone needs to find that, what's your channel name on YouTube there?
I think it's the JPster.
The JPster, which is also
search
your
for YouTube and Neotron. There's not many videos on the topic. You'll find it.
And that's also your handle in our community.
Yep.
Whoop. Ben froze again here.
I always wonder when I watch this whether it's you or whether it's Ben, but now I know it's Ben.
Well, that's why I jump in and yeah.
It's not meant to be me because I don't miss a beat from you guys, and I'm on a 100 megabit upload here in my office. So it shouldn't be happening, but maybe it's the computer or a codec or something. Anyway, I really do need to get going, but it's great seeing you guys, and thank you so much again, Jonathan, for joining us.
Absolutely.
Great to see you again, Bill.
It's a pleasure.
Yeah, good seeing you guys. Thank you again, Jonathan, for joining us.
And what's next Friday? Next Friday is
Christmas Eve.
It's Christmas, so we could still stream if we have a topic. If you're available, Bill, I can be available.
All right. Yeah,
December
let's see how it goes.
So we'll keep posted. Get on the Discord and keep your eye out there. If there's an announcement, we'll give you an announcement the day before. Yeah, cool. Great to see you all, and come back again.
All right. Thanks, everybody.
Bye.
Bye.